Now we're going to look at sizes of sets. The size of a set, or the number of elements in a set, is called the cardinal number or cardinality. We use those interchangeably. The cardinal number or cardinality of set A is represented by n of A. All right, so it's like a function of A, sort of. It's n, and then the set is put into the parentheses there. And so the cardinal number, if I were to find the cardinal number of each of these 5 sets, you really just count up the number of elements in the set, if possible, or determine the number of elements in the set. Maybe you're not counting them. So we would say the cardinality of A, in this case, the numbers 5, 6, 7, and up to 15, these are natural numbers between 5 and 15 inclusive, is, well, you just count them off. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 11. Okay? Or you could subtract them. 15 minus 5 is 10 and add 1 for the extra endpoint. But 11 will work. So there are 11 numbers in that set, which means the cardinality is 11. In set B here, this is the set containing all S's, where S is a state in the USA. All right, again, there are 50 states in the United States, and so the cardinality of that set is 50. So let's say n of B equals 50. The empty set is an interesting one. Its cardinality is 0 because there are no elements in that set. And so the cardinality, or n of C, is 0. Set D here, number 52, that's my soccer number. It's also the number of cards in a deck. Also the product of my 2 favorite numbers, 13 and 4. But anyway, 52 is actually 1. The cardinality is 1. Because there's only one number in that set. Okay. And also, the cardinality of the set E down here, this is all x's that are in the natural numbers and between 3 and 10 inclusive. And so again, you could just count those out. 3, 4, 5, 6, 7, 8, 9, 10. What's that? 8 numbers. And so the cardinality of E is equal to 8. So again, the cardinality is simply the number of elements in each of those sets. Okay. Now, what's interesting is that some sets have the same number of numbers in them. Okay. For instance, I could have the set of natural numbers such that n is in the natural numbers, and n is less than or equal to 50. Let's call this set F. Well, the cardinality of F is 50, right? It's all the natural numbers between, well, less than 50 or between 1 and 50, equivalently. And so here we have 2 sets that are equal. This set and the set of, 2 sets whose cardinalities are equal. We have this set F and this set B, which was the set of the states in the United States. Obviously, the sets themselves are not equal. This is a set of geographical areas. This is a set of numbers, but their cardinalities are the same. And so we say that 2 sets are equivalent we'll call them A and B. Doesn't matter. It could be F. I guess in this case it's F and B, but it doesn't matter. 2 sets A and B are, I'm writing this generally now, equivalent if their cardinalities are the same. In other words, n of A would have to equal n of B in order for that to be true. Okay? So those are called equivalent sets. equivalent sets contain the same number of elements, even if the elements themselves are not the same. Equal sets are sets that have exactly the same elements. Okay, so equal sets have exactly the same elements. So we would say in that case that A and B would be equal to each other if they actually had the same elements. I'm not talking about the A and B over on this side, these examples here. This is all separate from the examples that I'm working out. These are just definitions now. Okay? So two sets are equivalent if their cardinalities are the same. Two sets are equal if their actual elements are the same. In addition to that, you can repeat elements. You can have the number 5 show up multiple times in a set, and it really only counts once. In fact, repetitions we don't really even include. So if the number 5 showed up in a set 3 times, you'd only write it in once, and it only counts once towards the cardinality. And the order of the elements doesn't matter. You can scramble them around. Order is arbitrary in a set. You're just looking for the collection of elements, not the order in which they appear. So if you organize the United States by alphabetical, or if you organize them by size, it doesn't matter. It's still the same states, right? Okay, so anyway, we've got equivalent sets and equal sets. They mean different things in each case.